I am Keith Rice. I'm the technical director at CAD Sharp. Since 2011, we've been one of the premier providers of SolidWorks API and PDM API training and consulting in the area of software development. So we write add-ins, macros, standalones, all that good stuff. And I've also been a presenter at 3D Experience World for many years. So if you want the files for the presentation I'm going to give you, you can go to cadsharp.com/3dxw, and they're right here. This is the presentation I'm giving, and I'll be using PowerPoint from SolidWorks 2020 actually. Also, I'll mention real quick that we also are in the BOM synchronization space. So just real quick mention, if you have any need to move your bill of materials data to your ERP from PDM or SolidWorks over to whatever, NetSuite, Odoo, sharpsync.net. We developed a tool for that. So just wanted to mention that we also create that product. All right, I am going to open up, so I already have SolidWorks open, and I'm going to give a really, really brief PowerPoint presentation. And let me flip this. Okay, so SolidWorks API for total beginners is what this presentation is called. Let's do a little bit of audience participation first. How many of you have ever done anything with the API? And it could be as simple as recording a macro for fun, or it could be finding a macro online, could be even writing a macro from scratch. How many of you have done anything like that? And I think there's is there a raise hand
in SolidWorks or anywhere?
I think let's focus on SolidWorks and SolidWorks PDM. So I think there's like a raise hand tool in Zoom that I could see your hands. Otherwise, you can put it in the chat. But yeah, who's done anything with the SolidWorks API?
I've done a very simple one.
Okay. All right. Well, we have one person kind of involved. So this will be good. This will be a learning experience. Hopefully expose you to what the API is capable of. And then you can decide whether it'd be any use in your organization or for your workflow. So API stands for Application Programming Interface. Many programs and apps out there have APIs, whether they're online or locally installed. And the purpose is to allow programmers to extend that application's capabilities. So there's many ways to use the SolidWorks API in SolidWorks, many languages, many program types. We're only going to focus on one today, though, and that is the simplest way to use the SolidWorks API, and that is through SolidWorks macros using the Visual Basic for Applications programming language. So there's 4 ways that the SolidWorks API is used. First of all, to speed up repetitive tasks. That's probably the most common use case for macros. I'm going to show you some examples here in a moment. Then also just reducing user error.
One quick question. VBA is the only language supported anywhere in there, or we have alternatives?
Nope. VBA is definitely not the only one. It's just the simplest.
Yeah, you don't need to elaborate. I just wanted to set that reference point.
Yeah, I do want to mention this, though. This is worth noting. If we go back to the page I showed you on my website, one of the presentations I give pretty often at 3D Experience World is a presentation talking about the differences between all the program types and the languages. So if you want to do a deep dive into all those options, definitely check that out. That is the purpose of that presentation. All right, and then another use of the SolidWorks API, design automation. This is definitely taking it to the next level. We're not going to get that fancy in this presentation today. You can even create models from scratch with the SolidWorks API. And Usually a designer is not going to need to do that, because if you need to create configurations or variations of your model, obviously you'd use the built-in configuration or design table functionality. But there are some instances where you do need to create them from scratch, and I'll let you know. If you are following me on LinkedIn, you're more than welcome to follow me or connect with me. We will be in the next couple months announcing our involvement in a very cool generative AI startup that is basically developing a technology where you can take a picture of a model, a sketch even on a napkin, and it's going to, using AI, figure out how that would need to be parameterized in a CAD system, and then we convert it into an actual model using the SolidWorks API. So that's obviously very powerful. And then lastly, if you've ever used CAM software or something like that, that's a very, very obvious example of extending the capabilities of SolidWorks, because SolidWorks originally when it was developed did not have any built-in CAM tools. I think it does now, but those CAM tools or CPQ tools, configurator tools, whatever, would have been written with the SolidWorks API. All right, that is my presentation. Now we're going to actually look at some examples. Before I go any further, though, are there any questions up to this point? All right. So if you play paintball, you will recognize this model. This is the classic Tipman 98. Let's say that you design models like this that are kind of right-handed or left-handed, and boy, it sure would be nice if you had a way to quickly create a flipped version of that. And by the way, maybe they've even added that functionality into SolidWorks in the past few years. I don't know. I don't keep up with that real closely anymore. But at least a few years ago, the only way to do that quickly would have been to write a macro. Otherwise, you have to, select the appropriate plane, mirror the bodies, etc., join the bodies together, that kind of thing. Moreover, what if you had a whole folder of these models? That could be pretty tedious, pretty time consuming. So I'm going to demo a little macro I wrote that is going to take all these models, I think there's only 3 in the folder, and create flipped versions of them, or left-handed versions, however you want to think of it. The way I'm going to do that is, first of all, I have my macro toolbar up, which you could access by just right-clicking, toolbars, macro, of course, or you can access all macro functionality through Tools Macro. And I'm going to go to Run. Oh, before I go to Run, let me grab the folder location. So I'll just do a Control-C, and then I'm going to run the macro. And macros are .swp files. This is called create mirror. And I've designed it so the first thing it's going to do is prompt you for the directory. So I'll enter the directory I just copied, and then when I click OK, it's going to open up each of those models. Get the front plane. I believe that's a prerequisite. You need to have a plane called the front plane, and that's going to be the mirror plane. And then it will add the features necessary to create the flipped version. Okay, and I think I commented out the code that will actually save it, but you could have these be saved automatically. So in all these cases, what has happened is it has not only created the flip version, but it's created it as a separate configuration. So let's go to this. All right, so you can see how if this was done in bulk, that could save you quite a bit of time. I'm going to show you one more example. This is one of the first macros I ever wrote, in fact, and it does demonstrate some design automation. Gear Creator, which, by the way, if you download the files for this presentation, I do have more macros you can play with in there. This is Gear Creator. So this has a user form I created, and You can enter in a gear pitch diameter, calculate the rest of the values. You can decide whether you want to create a gear opinion, both gear width, choose the units. And if I click create, it should generate these from scratch. So as I mentioned, in real life, in your job, this type of macro is probably not going to be that useful because you'd probably just use configurations or design tables to create variants of a gear, but nevertheless, you can create features from scratch using the SolidWorks API, which brings me to another point that I get asked quite a lot. What can the SolidWorks API do? People will say, hey, I'd like to write a macro that does X, Y, and Z. Is that possible? The answer is yes. The SolidWorks API is absolutely massive. We're going to see that in a moment when we look at the SolidWorks API help. There's a very low chance that you cannot automate what you want to automate. SolidWorks API is very mature, very robust, and it has a whole team behind it at SolidWorks. It's not like this is just some kind of aside, something that some people threw together for fun. No, this was developed as part of the SolidWorks software from the beginning. Okay, so what we're going to do next is take a look at the macro recorder. And I might as well ask that. Is anybody, no, I guess nobody's even used the macro recorder. I don't need to ask that again. The absolute simplest way to use the SolidWorks API is through the macro recorder. So if you're not sure where to start and you just want to say that you did something API related, the macro recorder. Again, it's accessible through the macro toolbar. We already used the run macro button, but there's this other button called record. And I'm going to demo this, and we're going to see a couple things from this demo. First of all, we're going to see that you can record some functionality, obviously, but the other thing we're going to find out is just how messy the code is and how limited the functionality is. And that'll be a stepping stone then into writing our own macro from scratch, which is really what you need to do if you want to get serious about the SolidWorks API. Just as a demonstration though, let's click record. And I'm going to just create an extrude. First, I'm going to go to File, New, going to open a part, going to click on the front plane, insert a sketch, and then, oops, I'm going to go to circle, make it of an arbitrary size, then go to extrude, make this of an arbitrary length, click OK, and click Stop. Let's save this here. We'll call this macro 3. So saving it as an SWP. SWP, by the way, is what's called a binary format, meaning it's compiled. So you can't go out to your desktop, look at one of these SWPs, right click on it, and view the code. The only way to view the code is through the VB editor, as we're going to see in a moment. So I'll click Save. Let's just make sure that that macro even works, that it even recorded properly. So macro 3. Okay, it did. Let's now go to Edit Macro and go to macro 3. And I set the font size. It's pretty large in the VB editor. Normally it would not be this large, but I made it that large so that it'd be more visible to you. Hopefully you can read this. All right, so we are in what is called the Visual Basic Editor. This is something Microsoft created because VBA, Visual Basic, is a Microsoft language. This is not something that SolidWorks or Dassault created. And if you've ever written a macro in Excel, you would actually use the exact same environment. So you see that this has 40 lines of code. Just to demonstrate how messy, actually, I'm not going to go through and pare this down. I'll just show you the completed version. I just want you to note that it is 40 lines. If you were to look through here, I'm sure that some of the code would make sense to you. Like for example, new document, that's where it grabbed a particular template. Right, here's where the front plane got selected. Here's where the circle was created. You can probably guess that those 6 arguments correspond to the center point, and then wherever you placed the radius. And then down here is feature extrusion. That's where the extrude feature was created, and you'll notice that there's a whole lot of arguments. And that's because if you open up the property manager page for an extrude feature, there's lots of options associated with an extrude feature. So it's just giving you the option to specify those, everything from the length to the draft angle to whether the direction is flipped, etc. All right, so that was the recording. And the last time I did this presentation, I did pare it down to something much simpler. So I'm going to go back to...
Quick question.
Yeah, go ahead.
There's no way to save as any kind of a human readable format from the jump?
Nope, not with VBA macros. If you want to have your code under source control, as it's called within programming, like you would see on GitHub, something like that, then you need to use .NET programming languages, which is what you would use if you were writing an add-in or a standalone. But with VBA, it's in that compiled format. So there's a lot of pros and cons to using these different types, and I've just explained one of them. Again, reference that presentation I showed you earlier if you want to see more examples of that. Okay, so this is what would happen if I took the time to take that macro recorder code and pare it down to the absolute basics. Notice we've gone from 40 lines to 11 lines. So change some of the variable names. The point of me showing you this is that the macro recorder is really messy. You're not going to get high quality code out of it. You also can't, via the macro recorder, create conditional statements. You know, there's no way to record logic like if this happens, then do this, otherwise do something else. Also, there's some functionality that's just not recordable. Like if I were to record myself trying to add a custom property, it just wouldn't record it. So the macro recorder is a tool in your toolbox if you're using the SolidWorks API, but it's not a very impressive tool. If you want to get serious about the SolidWorks API, you have to learn some programming. And again, in this case, we're going to be using VBA today. And you have to learn how to use the SolidWorks API help and navigate the SolidWorks API object model. I'm going to cover all of that in brief so that you can see what it's like to write a macro from scratch. Now, I'll also say that if you have zero programming background, I'm not going to take the time to teach you how to program. And in fact, this presentation is going to feel a little bit like drinking from a fire hose. On our website, cadsharp.com, I have 10 free video tutorials on learning the basics of Visual Basic for applications. So go check those out if you do decide to get more serious. Actually, I'll just show you real quick under SolidWorks, developer training, SolidWorks API videos. We have an entire course on how to use macros with VBA, and quite a few lessons are free. So go check that out if you want. I don't have time to teach you all how to be full-blown programmers, so you're just going to have to bear with me. Any questions up to this point? Okay, let me show you what we're going to write from scratch. I'm going to open up another file, the support. And I do apologize, but you know, since this is a beginner presentation, I don't have time to show you the coolest, most complex macro ever. This is going to be a pretty simple macro. So this support has a particular dimension that is controlling the radius or diameter of these holes. And what I'm going to do is write a little macro that will let us automatically specify a new diameter for that hole, add that as a configuration, and the configuration name is going to be that new diameter in millimeters. So again, probably not a macro that would exist in real life because you'd probably just use design tables for this, but it will serve our purposes here. So let me show you the completed macro. I'm going to go to run, and here you go. There's a little user form. I don't think we're going to have time to create the user form in this today because I only have an hour. If I had a full hour and a half, we would. But in the final version that where I've created this macro, what we have is basically a list that's limiting the user to acceptable diameters. Because if you get too small, obviously it's meaningless, and if you get too large, then it's going to cut away at the base and not actually be a useful part. So let's go to say 15 millimeters, click add configuration, and just add another one, 20, and keep doing that. All right, so now if we go back here, you notice it not only added them, but it rebuilt the model, so I don't have to rebuild as I'm clicking through. That's all we're going to do, a little add configuration macro. So let's go back to reload, start over, and start writing this from scratch. So I'll go down to the macro toolbar, click new macro. Let's call this add config NYC, NYC swug. Click save. And we will now be in a fresh new clean slate as far as creating macros goes, which that's always going to involve 4 starting lines of code. The reason these lines of code are always going to be present is because the first thing we do whenever we're using the SolidWorks API is we need to get access to the SolidWorks application. So here is, I'm going to give you in the next 2 minutes the world's shortest programming lesson. That's as far as we're going to go. When you're programming, you're usually only doing one of 3 things, or maybe a combination of those at any one time. You are declaring a variable, assigning a value to a variable, or using that variable. And already we can see 2 of those. This dim SWApp as object is where a variable called SWApp is being declared. And that's what dim stands for. It means dimension. It's blue. It's a keyword. And the type is object. So you can think of us, when we write that and whenever we run this program, what is basically happening is the program is saying to the computer, create a bucket of a particular size in RAM that can hold what is called a pointer to the SolidWorks application. It's basically a memory address. We need to be able to point to where SolidWorks is in RAM. And so we need to create a bucket that will, a pointer shaped bucket that can hold that. And when you're writing in the SolidWorks API, technically a pointer is an object, but what we're going to do is use the more specific data type, which is sldworks.sldworks. This is the namespace. It's where all of the different interfaces in the SolidWorks API live. So you can see here. And then SLDWorks is the top level interface that gives us access to all other interfaces. So it makes sense that we would need to start there. And I'll go ahead. I'm actually going to put this within that sub procedure. Submain in sub, that's just a code block. It's saying, here's a chunk of code that's going to get run. So whenever we run the macro, we're actually calling the main sub procedure of this macro and it's getting run. And if we create a macro shortcut, which I'll show you how to do later, we'll point to the entry sub procedure, the one that we want to begin executing code. Okay. So we're in our code block, our sub procedure called main. We've declared a variable called SWApp. Then next thing we need to do is assign a value to that variable, and that's what's happening here. It's not enough to just have a bucket of a certain size. We need to actually put something in the bucket, right? And that's what's happening. This is where we actually get the pointer to the SolidWorks application. So we dimensioned it, and then we set it. Now, the third thing I said you can do in programming is use your variables. So let me demonstrate that real quick. If I type SWApp, send MSG to user, I'm going to show you how I know using the API help to use some of these API calls, as they're called. Send MSG to user, and we're going to type hello world. As you guess, this is going to send a message to the user. We specify what that message is as a string. When you specify a string within pretty much any programming language, it's going to be in quotes. Okay, so we can run this one of two ways. We can go back to run and find the macro on our hard disk and run it, or I can just click run up here in the toolbar. So it's going to make a SolidWorks style message box that says hello world. This is a complete program using the SolidWorks API. We did everything a programmer will ever do. We declared a variable, assigned a value to a variable, and then used a variable. That is your programming lesson. And now we're going to expand upon this to create that add configuration macro that I showed you earlier. Does anyone have any questions up to this point? Okay. Good. Let's keep going. So we're not going to display hello world to the user. But before I show you how to add a configuration, let's just look up real quick how I would have even known to write some of that code. I guess I'll add that back in for now. How would I have known, that I need to start off my code like this, set my application variable like this, use this API call? All right, so if we go back to SolidWorks and go to help, by default, you're going to have this button, impressed, use web help. I recommend turning that off so that when you click API help, it will bring up the local API help. Text is going to be a little small. I apologize for that. But the advantage of the local API help is that we have this index tab where we can search by topic. So if I just type in message box, look at that. There is a topic called message box. And if I click in here, there's probably going to be more often than not a list of a few options for you, and you'll just have to click through and explore them, research which one is going to work for you. Let's click into this one, send MSG to user 2. If I click in here, this is what a help page is going to look like. It's going to give the name of the API call, which can be a method or a property. And it's going to have the interface that it belongs to, which in the SolidWorks API help, the interface will have an I in front, even though in the code we don't include that I. It's just a little idiosyncrasy you need to know about. And then down here, it will say what arguments are involved, what the return value is, and it will also give examples. So this is key. This is how people learn to use the SolidWorks API. This is how I had to learn it, is playing around with examples. Obviously, I have that course online that can make this learning process for you a lot faster. But at some point, I had to get in here and just dig through and figure out how the code works. And pretty much any macro you look at, you're going to see the same thing. They're always creating that initial application variable, and they're setting it, and then just goes from there. And eventually we get down to where they used SWApp.send MSG to user 2. So SWApp represents the application. The interface associated with that is ISLDWorks. And if I click into ISLDWorks, you see it says provides direct and indirect access to all other interfaces. And if I were looking at the members page, here's all the things you can do in that interface, one of which is send MSG to user 2. Now, you might have noticed when I wrote that code earlier, that hello world code, I didn't use send MSG to user 2. I used send MSG to user. Why is that? Well, you're going to see API calls are versioned. basically, a newer version will just have a number appended to the end because they don't want to obsolete, or I should say deprecate the previous ones, because then legacy code won't work. So if we click back into the first one, what you'll notice is that this was just a simpler version of this API call. This one only took a message as a string, whereas the new one lets you also specify an icon, buttons, and get a return value. Why might we use an obsolete method? Well, in my case, it's just because it was simpler. All I wanted to do was tell something to the user. So there is no point in me using an API call where I have to mess with a bunch of arguments. And that is perfectly okay. When you are programming, you can use an obsolete method if it will get the job done. Also, I'll note that if you don't see a version at the bottom, it means that that API call is pretty ancient. Whereas, let me see if I can find another example. Add configuration 3, perhaps. Right here, availability 2001. So that's also pretty ancient by our standards. Point is, you can find out when an API call was added to make sure that, let's say you're giving the macro to somebody who's using an older version. You want it to be able to run in that version. As I said, though, the SolidWorks API is very robust at this point. So, and also you can just kind of see its size if I just scroll down through here. So going back to the question, is there anything the SolidWorks API can't do? And the answer is not much. And most of these API calls have been around for well over a decade. So you're not going to run into any backwards or forward compatibility issues.
If you have time, can you explain how to verify that the local help is installed and how to install it manually?
It should get installed automatically. You shouldn't have to specify something in particular. If it, for some reason, was not installed, though, you can just go here, SolidWorks API help, and it should pop up in Google. Doesn't really matter what year it is, again, because these have rarely changed. It is online. Again, the reason I use the local help is just I think it's easier to navigate. It's really no more complicated than that. But if you want to use the online one, go right ahead. Okay, so I've shown you how to do a little bit of VBA programming. I've shown you how to use the SolidWorks API help to some extent, and we'll keep using it as I develop this. And then I've shown you a little bit of how it's navigated. So let's start adding some code. We're about 30 minutes in, and all we have is a program that says hello world. Which, by the way, I'll mention this about programming in general. You watch the movies of Hollywood hackers who their fingers are flying and they're just adding tons of code to the screen. That's not at all what real programming is like. Real programming is about 95% researching and debugging and about 5% actually typing code, if that. So if researching annoys you, if you don't like debugging, if you don't like hurdles, programming can be very frustrating. But if you like puzzles and you like that reward at the end of being able to automate your process, then it is super cool and totally worth it. All right. So what is next? What do we actually have to do in that macro I was going to create? When I ran it, it brought up a user form. I'm going to wait and worry about the user interface later. Let's just think about core functionality. First thing we need to do is add a configuration. And then once we're in that active configuration, we need to get, let's see, this parameter, which is called hold diet at sketch 5. And then we need to change its value. And then we're going to find out that it's helpful if the macro rebuilds the model. And then, if we wanted, we could also save the model or something like that. But we kind of have these few steps we need to walk through. So let's do this. Let's use what's called a comment. So I'm just going to put an apostrophe. I'm going to type add configuration, and then we'll say change hole diameter, and yeah, we'll just go from there. But sometimes I like to just kind of write out, and you could think of it as chapter form, what I'm going to accomplish in the macro. All right, how do we add a configuration? Well, let's go back to the SolidWorks API help. And back in my trusty index tab, I can type configuration, and look at that. There's a whole bunch of information on this topic, one of which is add. So let's just double click on that. And looks like my API help wants to be funky. Nice. Oh, there we go. Okay, only two options, add configuration 3 and I add configuration 3. Here's another pro tip for you. If you ever see a method or a property that has an I in front, you can just ignore it. Not even going to explain why. You can just take my word for it because Keith Rice said so. So just pretend this doesn't exist. There's add configuration 3. Click in here. Adds a new configuration to this model document. That's exactly what we want. Has a few parameters, most of which we don't care about. But you can look through those if you want, and then we can also find out if the configuration was successfully added if we want, and then maybe check for that. So if I wanted, I could go in here and look at a help example, which, by the way, as you can imagine, as an API call gets more obscure, the less likely it is to have an API help example. But hopefully by the time you're using obscure API calls, you don't need to rely as much on examples. All right, I'll click back in here. What you'll notice, I'll go back here. What you'll notice is that this method is not part of SOLIDWORKS, which is that interface we already have access to. This is part of iModelDoc2. So right now in our code, we have access to the application, and that lets us do high-level application things, like send messages to the user. There's also stuff like you can close all documents, you can exit SolidWorks, etc. But adding configuration, that is more at the model level. So I'm just going to skip ahead here and show you what you'd eventually figure out you need to do if you were to look into the help. What we need to do is declare another variable as a model, which is ModelDoc2, and that's going to contain functionality related to any document type, part, assembly, or drawing. So as you can imagine, there are interfaces for the specific document types, but adding a configuration is possible in a few document types, so it's considered at the model level. And then I'm going to say set SW model equals, and again, don't have time to show you how I would have figured this out in the API help, but I can tell you from experience that we need to use a property that belongs to that ISLD works interface called ActiveDoc. And that is going to return the pointer to the active model document. Now, we have access to iModelDoc2, so now I should be able to use add configuration 3. So this is the name of my iModelDoc2 variable. So I'll type swModel dot, and if you look through that list, here's all of our model-related API calls, one of which is add configuration 3. So click that, hit space, oops. And it brings up a nice little menu showing us what arguments are involved. Let's just hard code something for now. The rest I am going to ignore using empty. And let's test this out. Okay. Yep, so it worked. Now, there shouldn't be any difference between these configurations, right? Because we haven't actually changed the diameter. Let's reload this. I know I'm going a little fast, but what I just showed you where you use the SolidWorks help to kind of figure out how to navigate through it, how to navigate through the SolidWorks API object model, as it's called, because obviously you start at the top level with the ISLDWorks interface, and then you drill down to models, and then maybe a part, and then a body, and then a face, and then, you know, things like that. If you needed to change the color, get the area, that is all called navigating the SolidWorks API object model. That's the secret sauce to using the SolidWorks API, learning how to do that with the SolidWorks API help. And for every student I've ever worked with, there's always that light bulb moment. Once they figure it out, once it clicks, they get it, and they say to me, man, I just feel like with enough time, I could program anything. And that's true. After that, it's just researching, it's debugging, it's trial and error. Any questions up to this point? Okay. Let's now change the hole diameter. So I am not going to show you in the API help how I would have figured all this out. I will say if I was in the API help, probably would have just typed in dimension and then actually not even certain which I would use in here. But it's obvious that we want to change the value of a dimension. So I'm just going to copy some code now so we can keep moving along here. What we need to do is create another variable for a SolidWorks dimension. So there's our dimension pointer sized bucket, and then say set swdim, because I've declared it, but now I need to put something in the bucket. Set swdim equals SW model, and the API call we want to use here is called parameter. This has one argument, string in as string. That's not very specific, but if we were to look in the API help, we would find out that that just needs to be the dimension name, which we go back here. Let's look at that again. Oops. Whole dia at sketch 5. Whole dia at sketch 5. So again, if I were to look this up in the API help, we should be able to see some examples, and who knows how long it would have taken you to figure out that this method is the one you need to use. Maybe you would have seen it in an example eventually, but that's just kind of programming. That's what you'll do. You'll figure out based on these examples and the API help what you need to type. And then this example actually uses the next API call that we want to use as well, because we have the parameter, we have the dimension, but now we need to do something with it. If I were to just run this code, it wouldn't do anything different from last time I ran it. Let's actually change the value of the dimension. So I'm going to say swdim.setSystemValue. So this is an API call that belongs to that iDimension interface. Should make sense that we need to get access to a particular dimension before we can set its value. And we're going to use setSystemValue3. So as the name implies, it wants the value in system units. Does anyone want to impress me and tell me what system units are in SolidWorks? I will tell you that they are not freedom units. It is meters and kilograms. Sad. But we put in 15, and then we ignore those other arguments, which I will specify using empty, which I'll just mention. The other arguments are basically saying, do you want to apply this new dimension value just to this configuration or to certain configurations? And then you can specify a list of names. We don't care about that, so we're just ignoring them by using empty, which will assign whatever their default value is. All right, so let's try this out now. So notice I had to click off of the configuration and then click back to the new one. That's because a rebuild didn't happen automatically. Now if I click rebuild, oops, the base got wiped out. Well, it should be obvious why the base got wiped out. We go down here to sketch. Remember, I said we are entering that as system units. So 15 would be 15 meters, not 15 millimeters. So let's reload this, go back in our code, and divide this by 1,000. And there you go. There's your 15 millimeters.
That system units is a hard-coded setting?
Yeah, from the perspective of the SolidWorks API, the system units are always meters, kilograms, radians. You can use an API call that's just called set value. Doesn't have system in there, that will use the current document units, but I like using the system settings so that I'm always in control and can just make sure that the proper conversion is occurring. Let's also rebuild the model so we don't have to keep doing it ourselves. So as you can imagine, I would go to the SolidWorks API help, I would type in rebuild, and eventually I would discover that there's two API calls. There's one that does the equivalent of a force rebuild and one that does the equivalent of an edit rebuild. We'll just use force rebuild because it's simpler. So that belongs to iModelDoc2. Do we have access to iModelDoc2 in our code? The answer is yes. We already got access to it right up here. So I should just be able to type swmodel forced rebuild 3. Top only is just asking whether we want the top level of the assembly to rebuild. That's not relevant in our case, so I can just put in empty. Now let's try this out again. Reload. And notice we don't have to go through any kind of rebuild process to look at our results. So we've created a pretty bare bones version of this macro. Now the reason this is not a usable macro, one that we would want to give to our coworker, is obviously this value is hard coded. It's just putting in 15 mm for the name and then 15 millimeters for the value. What we need to do next is get user input so they can specify the diameter size. Before we do that though, we do have one question. How does using API make my work or design faster? So in this case, the example that I'm showing, hopefully you can see how if we had some kind of repetitive task, like let's say we were occasionally adding one-off configurations to our models that were, in this case, just modifying a particular dimension, a macro would save us a little bit of time. As I mentioned earlier, this particular macro is a little bit contrived. You'd probably use design tables maybe to generate a bunch of configurations. But ultimately, whenever we use macros, we're generally just trying to speed up repetitive tasks and also reduce user error, because in this example, we're going to create the little user input form. The user will be able to input their desired hole size, and then we don't have to worry about accidentally typing in the wrong number or giving the configuration the wrong name or forgetting to rebuild, forgetting to save, etc. So yeah, the value is both speeding up repetitive tasks and also reducing user error. Okay, let's add the world's simplest user form. I'm not even going to create a full-blown VBA user form. Instead, I'm going to use a built-in VB function called input box. Let's say dim int diameter as integer. So this is not a SolidWorks API object type. This is just a plain old number that's available through Visual Basic for applications. And we're going to say int diameter equals input box. That's the name of the VBA function that will create a little user form for us. And this is only going to let us input one value. Obviously, if we wanted to get fancier, we'd have to create a full-blown user form. But it's going to take a prompt. We'll say specify the dimension value in millimeters. And then I need to take this, so I will copy it, and then down here, remove that 15, paste it in here, and I'm going to use the concatenation symbol. That's an ampersand. So VBA will automatically convert that to a string and then concatenate it with the millimeters. And then down here, we'll replace the 15 with int diameter. So let's save that and go back to SolidWorks. Reload this. And let's actually run it from here. Run macro. Specify the dimension value in millimeters, 15. Click OK. And there you go. So I'm not going to go through how to create a full-blown user form. We don't have time. But if you download the lesson files, you can take a look at the completed version of this macro that not only contains a user form, but also has error handling. It checks to make sure a part is open, because right now there's actually nothing stopping the user from running this just in the SolidWorks home screen, which is going to cause a crash. It's going to make sure the document type is part. It's going to save the model, etc. So a lot more could be added on here, but in our case, we're just keeping it really simple. The very last thing I'm going to show you is how you would create a shortcut. Actually, you can see from the last SWG meeting I did where we added it there. But basically, you're going to right-click, go to Customize, Commands, and Macro. And then New Macro button. We'll drag this out here. Specify the location of the macro. And then method, this is important. Remember how I said that we want that main sub-procedure to be our entry point? If you had multiple sub-procedures, this is where you would specify which one is the entry point. So click that, click OK, click OK. And there is our add config NYC SWG. So let's click that again. Put in 20. And there you go. That is how you would write a little macro from scratch. So believe it or not, I've given you all of the foundational building blocks for using the SolidWorks API. I've shown you how to create a macro with VBA. I've shown you how to use the SolidWorks API help. And I've explained a little bit about the object model. Obviously, I'm sure this felt like drinking from a fire hose, but nevertheless, this should give you some kind of idea if this is interesting to you, whether you want to learn it. And like I said, we have a whole bunch of resources on our website if you want to take this to the next level. So I will end it there and open it up for questions from anyone.
I'm in the early stages of putting together a small training operation in the New York area. I think I can get pretty cozy with this sort of thing because I was raised by a C++ guy, but the problem is I don't know how comfortable it's going to be for people at entry level. What do you think?
So I've taught SolidWorks API, obviously, quite a bit to beginners. And I'll note this right away. Most of the people I know who are using SolidWorks API are self-taught developers. They are mechanical engineers, mechanical designers, industrial designers, etc. that decided that SolidWorks API would be useful for them, so they taught themselves. And you can use the API help. The course I made obviously is meant to reduce a lot of the friction, but this is absolutely something that is approachable by non-formal degreed programmers. You don't need a computer science degree to do this. So I'd be optimistic. Obviously it's takes some wherewithal and it takes a little bit of work, but I think within 20 to 30 hours, usually the API really clicks for people. They have that eureka moment where they understand how to use the SolidWorks API object model. And from then on, it's kind of the sky's the limit. It's just, honestly, I think the biggest challenge a lot of SolidWorks API users have is just convincing their superiors, yes, it would be worth it if you let me take the time to write a little macro program that would speed up the work of me and my
My only
coworkers.
concern is odds are I'm not even going to be dealing with people at that level. Like we're looking at people who are operators with maybe a high school diploma, but 20 to 30 hours sounds pretty sane.
Yeah. Again, I'm not promoting my course online just to be self-promotional. Yeah. It will actually cut down the number of hours because I want this to be a resource for the community. This is all
where are
free.
You geographically for reference?
I'm near Portland. Yeah, so the other side of the country. But
no, it's like I have exactly zero interest in competing with anyone whatsoever because I'm literally that tiny, or I will be, hopefully. So the more what's that they say? Absence makes the heart grow fonder.
Yeah, sure. Yep. So this will run you through the absolute basics of VBA, so you at least have that out of the way, and then you can kind of go from there.
Hey Keith, I have a question.
Sure.
So, I mean, obviously the APIs that you showed us right now are like, well, what we did right now is not like fully representative of what would it take to create your first API per se. So like, in your opinion, like on average or roughly, how long would it take an absolute beginner to kind of figure it out? Like if you kind of, I mean, say you know someone who's already involved or knows how to use SolidWorks, but wants and maybe a little bit of Visual Basic, but would want to like go into creating like a macro like this without this guidance of like you saying this is what we need.
Yeah, I would say, if they have a sufficient understanding of SolidWorks, and let's also say that they have like run through maybe these videos that just quickly show you how absolute basics of VBA. I would say it is going to be about 10 to 20 hours to kind of get it under your belt. There's going to be a little bit of a period that feels like you're banging your head against the wall. That's unavoidable, but there is always that clicking moment, and it's once you realize how to get access to certain interfaces that let you do what you need. You kind of just end up working backwards, really. Like, let's say I wanted to write a macro that prints all of the areas of faces that are circular, planar, and planar and pointed in the Y direction. Well, you can start backwards. Like, here is iFace2 get area, and then that raises the question, okay, well, how do I get access to iFace2? Well, you go down here to this accessors list. You can see all the API calls that will give you access to it. You figure out which one is relevant to your situation. It's probably going to be iBody get faces. Okay, how do I get access to iBody? Click in here. Here's all the accessors. Here is iPart.doc get bodies too. That will get you access to all bodies in a part. How do you get access to iPart? Click in here. And you'll go through the examples and help files and realize you just set it equal to iModelDoc2. And then how do you get access to iModelDoc2? Well, I already showed you. It's through that API call called ActiveDoc. And then how do you get access to that? Well, you need access to the ISLDWorks pointer, which you have access to you anyway, because that's given to you at the top of the code. So do you see how I just went to my end point and then just worked backwards? As literally what you're going to eventually start doing. And everything I just explained might take you an hour or 2 hours, but that's all you're going to be doing is working backwards like that.
I see. So like pretty much understanding what you want to do in the end run and then kind of like
Yeah.
going through the documentation up to saying your where you can define your values.
Yep. And I know we're almost out of time. I will answer one question though that I always get asked, and maybe it's on someone's mind. Can I use Chat GPT? Can I just go to Chat GPT, type in, write me a SolidWorks API macro that will print all the, all the faces of, or the areas of faces that are planar and in the Y direction? The answer is that ChatGPT, first of all those AIs, they're large language models. They have to be fed the right data, and just being fed the SolidWorks API help, which is I think all they're working off of, is really not sufficient to get quality code. So the last time I have played around with ChatGPT, it did not give out very good results. Maybe that'll change in the future, but I'll also point this out about AI. AI will actually make up code. So it looks like it knows what it's doing, but it's not real and it doesn't work. That just blows my mind that there's not even like a disclaimer, like, hey, we see that API call, we just pulled that out of our digital rear. So just keep that in mind. You are going to have to probably take a more manual approach to using the SolidWorks API. You're not going to.
Daddy always says artificial intelligence will never overcome the power of natural stupidity.
Yep. I agree. So you'll be banging your head against the wall some. You won't be able to use ChatGPT or DeepSeek to just churn out your macro. Let's see. We got a question. Hello, out of curiosity. Oh, that's a question for you, I think, Stephanie. So I think that's probably it for me, unless there's any other questions for me.
Yeah, that's great. Well, thank you so much, Keith. This was really interesting. I really think that I've kind of, I mean, my exposure to APIs has been just on the macro. So I was like, let's see how much we can cover in an hour. But I think you really gave a very good foundation of just where to start. So I really appreciate it. Thank you so much.
Right. No, thank you for having me.